Solve problem 7.4. Collision with a parked car. A moving truck strikes a car parked in the breakdown lane of a highway. During the collision, the vehicles stick together and slide to a stop. The moving truck has a total mass of 1982 kg, including the driver, and the parked car has a total mass of 966 kg. If the vehicle slid 10.5 meter before coming to rest, how fast was the truck going? The coefficient of kinetic friction between the tires and the road is 0.350. So here we have a truck that is moving with an initial speed and it collides with a car which is parked. Mass of the truck, which we write as mt, is 1982 kg, whereas mass of the car is 966 kg, and the initial speed of car is 0 as it is parked. After collision, they stick to each other and move with a common speed v. We need to find what is the initial speed with which the truck was moving. Now, this is an example of inelastic collision, and we are going to use the law of conservation of momentum to find the final speed v with which the car and the truck were moving after collision. So from the law of conservation of momentum, we know that momentum before collision must be equal to momentum after. So we write P initial to be equal to P final. Momentum before collision is the sum of momentum of the truck and the car. So for the truck, we write mass of the truck times velocity of the truck. Since the car is initially parked, it has velocity as 0. And since its velocity is 0, momentum of car before collision will also be 0. After collision, they stick together. So we will combine their masses and we write mass of the composite to be mass of the truck plus mass of the car. And they move with a common speed v. We can rearrange the term to write v as mass of truck, initial velocity of truck over mass of truck plus mass of car. This is the final speed with which they are moving after collision. So I will call this as equation 1. Now let's discuss the part of the problem after collision. After collision, the truck and the car stick to each other and move with a velocity v. They travel a distance of 10.5 meter and then come to a stop. They come to a stop because of the force of friction. So whatever kinetic energy they had right after collision is used to do work against the force of friction before they come to a stop. So we can write work done against the force of friction is equal to change in kinetic energy of the system after collision. Work done is defined as force times the displacement. And this work is positive if force and displacement are in the same direction, and it is negative if they are opposite. And we know that force of friction always acts in direction opposite to displacement. So if the combination of truck and car were going to the right, the force of friction will be towards the left. So work done by the force of friction will be negative force of friction times the displacement. So we can write this as negative F times D. Change in kinetic energy is final kinetic energy minus initial kinetic energy. Final kinetic energy of the system is 0 as they come to a stop. So we get negative F times T equals negative K initial. You can cancel off the negative sign. That gives you force of friction times T equals K initial. Now force of friction F is given as mu K times the normal force. So we will rewrite this as mu K times normal into T equals initial kinetic energy. Now this initial kinetic energy is the kinetic energy right after collision, not the initial kinetic energy of the system before collision. So right after the collision, when they stick to each other and move with a combined speed v. Now let's solve this further. The normal force will be equal to the force due to gravity because force due to gravity of this combined system will be acting down and the normal force will be opposite to it. So you can get the normal force in as mass of the truck plus mass of the car into g. So let's substitute that here. You get mu k. For normal, I'm gonna write mass of the truck plus mass of the car into g times t equals initial kinetic energy after collision will be half. Again, combined mass of the truck plus mass of the car into v squared, where v is their common velocity. Now we can cancel off this term over here because it's present on both sides of the equation and it is multiplied with each term. And then we are left with mu k g t equals v squared by 2. Now let's move 2 to the other side and take square root to write in terms of v. So we get v equals square root 2 mu k g times t. Now substitute for v from equation 1. We write v as mass of the truck into initial velocity of the truck over mt plus mc equals square root 2 mu k g times t. I want to find the initial speed of the truck, so we can multiply with the term in the denominator and divide with the term in the numerator here. We get v initial t to be equal to mt plus mc square root 2 mu k g times t over mt. Now let's substitute. I get v initial for truck to be equal to mass of the truck is 1982. Mass of the car is 966 square root. Mu k is 0.350. G is 9.81. And the distance covered is 10.5 divided by mass of the truck, which is 1982. And when you solve this, you get the initial speed of the truck to be equal to 12.6 meters per second.